In this video, we're going to talk about factoring using the difference of squares. So let's start off with this expression here. A minus b times a plus b. And let's multiply it out. So a times a is a squared. A times b is plus ab. Minus b times a is minus ab. Minus b times b is minus b squared. When we do this, the middle two terms will cancel, and we are left with a squared minus b squared. And this is a difference of squares. So if we ever have an expression where there is a square and we are subtracting another square from it, we can rewrite it as a minus b times a plus b. So let's look at a few examples to show you what I mean. First, let's say we have 64y squared minus 49. We can rewrite this as 8y squared minus 7 squared. And then we can treat this 8y as our a and this 7 as our b. Now we can write a new expression, which is 8y minus 7 times 8y plus 7. And this is just following that pattern we had before of a minus b times a plus b. And so this would be the final factored form. But what we can do is multiply it back out just to see if we get the right answer. So we get 64y squared plus 56y minus 56y minus 49. And so again, these middle terms cancel out, and we are left with what we started with, 64y squared minus 49. So, checks out. Let's look at another example. This time, say we have 3x squared minus 147. So 3 is not a perfect square, but what we can do is take the greatest common factor out of these. It's going to be 3, and that's going to leave us with x squared minus 49. And so this looks a whole lot more like a difference of squares. And we can rewrite this as x squared minus 7 squared. We'll keep our 3 here. So this x is going to act as our a, and this 7 is going to be our b. So we can rewrite the inside of this parentheses as x minus 7 times x plus 7, and we'll keep our 3 out front. And this is the factored form. Try a couple more. Now let's say we have 9 minus 25x squared. So this example really just shows that it doesn't matter if the x squared is over here or over here. As long as both terms are a perfect square, then we can use our formula. So this can be rewritten as 3 squared minus 5x squared. A over here, b over here, and so we can write it out as 3 minus 5x times 3 plus 5x. And there is the factored form of that expression. Now we can look at one more. 2x squared minus 162. So again, both of these numbers don't look like something we're familiar with, but what we can do is pull a 2 out of this expression. It's going to leave us with x squared minus 81 on the inside, and this is a difference of squares. So we can rewrite it as 2x minus 9 times x plus 9. And a quick check, we'll multiply it back out. We get x squared plus 9x minus 9x, and then minus 81. These cancel. We get x squared minus 81, and then we can multiply it all by 2 again. 2x squared minus 162. So our factored form looks like that.